all of us want to build like the best possible solution and win as many users by building something like Standard Schema and improve the web and our community in general.
Hello, welcome to devtools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. We're really excited today to have Fabian Hiller on with us. So Fabian, you are the creator of ValiBot and Formisch, and you are also one of the co-creators of Standard Schema. And we're really excited to chat about that. But before we dive into our topic, we'd love to just hear a little bit more about you. So would you like to give us an intro?
Thank you. Yes, I can do that. Yes, most know me about the work I did for ValiBot, Formisch, and a few other things, and my involvement in open source. And besides of that, I work as a software engineer. I'm originally from Germany. Before I went to college, I started two companies, one kind of agency or service business, and then about 2 years later, a startup where we helped influencers sell advertisements. And then later on, I went to college and I always did many things on the side. I produced video courses for, I think it's the largest IT publisher in Europe, where I teach HTML, CSS, Tailwind, Bootstrap, and many more things. Also about design and components, which was back then, I would say, still a newer topic. And yeah, and I got slowly involved into open source. I was probably one of the earlier React users. I built a really huge application on top of hooks while it was still in beta. And I always loved the community. And then at some point, I felt ready to give back or contribute and build my own projects. And the first public project was Modular Forms that some maybe know. And then that was also kind of my intro to Ryan Cagnado, the creator of SolidShares, and also then later on my intro to Misko Havery, the creator of Angular. And that's how everything started. And then ValiBot, I made some good decisions when building ValiBot, and also, of course, had a little bit of luck. And ValiBot became really popular really quickly and is now probably among the most popular schema libraries. And yeah, and last year I somehow ended up building a form library, but yeah, we can talk about that later. And yeah, I live right now in New York, and I think that's probably the most important information.
Yeah, so I want to dig into why you started ValiBot and like where it came from. So while I was doing my research for you, you actually did this as part of your bachelor's thesis, which before this, I didn't even know there was a thing as a bachelor's thesis. So that's interesting. But I also found it interesting that like they let you focus on like open source library work. So can you kind of tell us how that all came together?
Yeah. So my initial idea was to write a thesis about education. I was really heavily in education, for example, with the video courses I created, but I also did a lot of YouTube before that. And I'm also part of the Studienstiftung. That's an organization from Germany that sponsors a really small part of students with like excellent performance. And there is like a really specific application to get into. And one part is to hold a presentation. And my presentation there was about education. And I think I have, and back then had many great ideas on how for example, education in Germany, but maybe in the world in general, could be improved. And so that was my initial idea for the bachelor thesis. But it turned out to be really, really hard to get like the best people in the world, especially entrepreneurs, to supervise the thesis. I really tried hard to get to them, but they are often busy with other things and have probably not a huge benefit in doing that. And so I thought, okay, maybe let's go in a completely different direction. And this direction was open source because I was already heavily involved in open source. And I, worked hard to build up a network. It was not intentionally, it just happened because I guess my work was okay. And that's how I ended up asking Ryan and Misko to supervise my bachelor thesis. They both knew each other, and after I could convince one of them, the other joined. So that was great. And then I came up with a few topics, and then at the end we kind of decided that building a schema library could be the best scope. I also had ideas about improvements for solid shares and improvements for code. But the bachelor thesis has like a scope of about 3 months. And some people maybe only do research and then bring it together, but I had to do research, I had to implement a library and then to write everything down. So a 3 months time frame looked great for this idea. And the reason why a schema library was probably that I was probably among the earlier SOT users, and I saw a huge potential in SOT, and I also used it heavily. But since I was also looking at that time into solid shares and other solutions that are in general more efficient, usually with a smaller bundle size, but also with a faster runtime, I also looked for ways on how we could reduce SOT and make it smaller to not like blew up the bundle. Of course, if we have like Next.js and like a huge component library, at some point it doesn't matter. But if you have a really slim setup, for example, with solid shares, then SOT quickly doubles your bundle. And so there were the idea on investigating if it's possible to reduce the bundle size. And that's basically my bachelor thesis. I proved it on top of a schema library, but the thesis is mostly or partly written in a way so that it could be applied to basically any JavaScript library. And we also saw this movement for other libraries like a few years ago, Firebase rewrote their library in a mostly modular pattern, and a few others tried or did it too. And I hope I could also inspire some people to look into that. And in simple words, two outcomes or two insights from the thesis was that you could achieve a smaller bundle size by either building a modular architecture or by using a compiler. There is a third option, but that depends on pre-processing step. It's basically maybe almost like a compiler, but for example, if we would go beyond what roll up or roll down of a pre-shake, you would also load a bundle size. But yeah, that's another topic. I know that some tech companies like Google, they have their own compilers that partly does that. But if you split out class methods and so on, that gets risky, and that's why you need a lot of tests to make sure that you don't break anything. And that's why probably most popular bundles don't go that far right now. And that's kind of how ValiBot started. And based on the research I did, I implemented the library, and then I think before I actually started writing the thesis, announced it together with my supervisors, and we got a lot of traction on X. I think more than 500,000 impressions, probably even more because other people reposted it or made their own posts on top of the announcement we did. And yeah, that's how we got traction and a lot of feedback. And while writing my thesis, the library involved a lot because people recommended improvements. And yeah, that's how kind of it all started.
It's awesome to have a thesis that you're writing where it's like you're not doing a thing just like in a hole. You're just like researching by yourself, trying to figure something out. You have like a bunch of people coming in. I mean, I know you usually have an advisor, but it's cool to have external folks pitching in. Also, I'll say I've read a few different people's thesis in my time, and they're not always the easiest thing to read. I feel like academic papers in general, like some of them have this quality where it's like hard to read, but like yours is very delightful. It's like the best read me, like for like you can really sit down and kind of understand the scope and like the domain and like how it's built and everything, and it's just so easy, and
Yeah.
that's pretty huge. So props for that.
Yeah, thank you. And I think that's actually like the hardest part, explaining for some people complicated things really easy so that even someone with no or less background or context can understand it. And I think that's something I try to do with all the work I do and publish. And you probably see this pattern in the source code, but also in the repository. I try to keep things clean and simple, but still high professional and with high quality. And yeah, thanks.
How did Misko and Ryan influence the sort of design of the app or your thesis? Like, what was their role, and like, how did they help shape it?
You're talking about my supervisors?
Yeah, your supervisors when
Okay.
doing your thesis.
I would say the way I work is mostly very independent, and that also makes sense and is important if you work with people like Ryan or Misko, because of course they have also a lot to do on their own. So I basically checked in with them regularly and updated them. We had a Discord chat together, and I think we had like 2 or 3 calls where I updated them, showed the results, and then got feedback. And besides, and of course, they then read the thesis and also reported back to my university. But besides of that work, maybe the even more important part was publishing the library and doing work on social media. Yeah, because that basically made the work and the library visible to others and basically started this whole open source project or movement.
Yeah, I think I was on Twitter at the time and I saw a lot of ValiBot when you first were advertising it. It was all over the place.
Yeah.
But let's drill down into a little bit of the uniqueness of the library. You said that it's like 95% smaller than Zod. That's a huge difference in size. What like design decisions did you make to like make that possible? And why wouldn't it be possible in something like Zod?
The main reason so for ValiBot is that ValiBot builds on a modular architecture. That basically means every function has only one functionality, and multiple functions can be combined with an toothed out API design. And in really, really simple words, when you use ValiBot, you only import what you use. And because imports are treated as static, they can be reshaken at build time. And that means any dead code that would never be executed can be removed. And because of that, in most cases, the bundle that ValiBot adds to your JavaScript bundle, and we're talking about the library bundle, not the code you write, it's probably around 1 to 2 kilobytes. Even true, the library in total is probably around 10 or 11 or 12 kilobytes. And the library is also implemented extremely consistent. And for example, if you use the string schema, that adds probably around 400 something, maybe 500 bytes. But if you add the number schema, it probably only adds like 50 to 70 bytes on top of that. Because we not only focused on the modularity, we also focus on being able to have achieve a high compression rate when bundling or when gzipping the library code.
So it's like using the same identifiers and trying to do things to make sure that it's like internally consistent, I suppose.
Yeah, also I would put it this way: when you build a modular library, the start is the hardest part, because there you have to figure out how you can combine or connect the individual building blocks. So what contracts are you using? And because a modular architecture forces you on think a lot about that in the beginning, your API, if you don't screw it up, becomes kind of automatically somewhat consistent, because you need to design it in a way that every building block can basically be replaced. And that's what is possible with ValiBot. If you don't like how an action works, just copy it over, change it, and put in your own code. And that's really simple. And that's not that simple or not possible with other libraries that are maybe built on classes, also object-oriented, because it's way harder to insert anything into.
So one of Zod's major selling points is the TypeScript integration. I think that's why the API exists as it is. It uses the TypeScript builder pattern, which is used in a lot of different other libraries to get really, really nice types. Does ValiBot have something similar? Does TypeScript work in a similar way with the library?
Yes, it does, but we need to distinguish here. So what are you referring on, the types reproduce, or are you referring on the editor DX when you type?
A little bit of both.
Okay, so one of Zod's greatest benefits is maybe also the reason why ValiBot is so popular, and that's what, as you said, a builder pattern, where you basically chain methods. The cool part with that is, if you call a method, you can write the library in a way that it knows its own context, and if you put a dot, then TypeScript will only recommend the things that are actually available and make sense. And that's really great, because that allows many users to use Zod without reading the documentation or do a lot of research, because they can just start with a basic type like string, enter a dot, and then see what's available. That's a little bit different with ValiBot because it's a modular library. So there is a little bit more effort necessary. We could solve that within the Xcode extension, but so far there was not enough incentives, I'm not sure if that's the right word, to do it. So I think this would be solvable also with modular library, but with more effort. And for modular library to get pretty close, it's super important that you have a really simple and strong mental model. For ValiBot, we have a mental model with 3 building blocks. The first are schemas that are basic data types like string, object, date, and so on. Then we have actions. Actions actions, they can validate an already known type and, for example, can validate their format. For example, we could validate that a string matches an email. They can also do transformations, and they can also add metadata. And the third building block in ValiBot are methods that allow you to use or modify a schema or action. And together, they allow to build complex schemas. For example, one of our most popular methods is our pipe API that basically appends a pipe to the first schema that you pass to the pipe. And it's super flexible because you can say pipe string, and then you can put whatever you want after that. You can validate its format, you can perform transformations, you can append metadata, and basically the data flows through the pipe in a sequential way. And that's probably also one of the features users love a lot about ValiBot because it's highly flexible. And I think doing the same with SOT in some cases is a lot more cucumbers. Hope I pronounced it right.
Yeah. I do like the examples are very legible, and it's nice, especially when you have messages in there. They kind of like stack linearly because it's just this pipeline of actions, which is kind of cool. I want to switch topics a little bit. So one of the to tie this all back together, one of the things that I liked about your thesis is you talked about the ecosystem. You sort of acknowledged like Zod and Archetype and Typia. I forget what the other one was. And it was like cool to see that like view of the landscape and their trade-offs and the performance and everything. But it's funny that now you've come together with Colin and David Blass, who's the creator of Archetype. So Colin's creator of Zod and David's the creator of Archetype, to sort of like do a mind meld and create Standard Schema, which is this sort of unifying interface for schema libraries. And I'd love to hear a little bit more, like, how did that come about? Like, because it does seem like y'all, I mean, I don't want to say are competitors, but like you're alternatives in the same sort of space. So you kind of competitors. So like, how did that come about?
Yeah, so maybe it's good to know that even before Standard Schema happened, I talked to Colin and also to David. And I think David even read my thesis in advance, so I at least exchanged ideas with him, because I also looked at Archetype and also questions back then. So there was already a connection, probably pure of like interest in each other and what we're doing. And yeah, it's funny, of course, we are somehow competing with each other, but I think in like a cool way. I think all of us, of course, want to build like the best possible solution and win as many users as they can. But I do also strongly believe that all of us see the broader impact we can have by building something like Standard Schema and improve the web and our community in general. And Standard Schema happened because Colin, creator of Zod, mentioned the initial idea many, many years ago. Probably now 4 or 5 years ago. I'm not totally sure, but I think it's mentioned in our README or on our website. Or it was mentioned, I'm not sure anymore because we probably updated it. He tweeted about that, and that was the time I was building modular forms, and I already saw a value in such an unified interface. But I haven't started ValiBot, and there was not a huge incentive in pushing that further. And I think about 2 years after he posted that, I picked it up again and talked to Colin because I saw a huge benefit for ValiBot, but also for the ecosystem, if we create such an interface. ValiBot struggled at that time, being kind of ignored by popular or newer popular libraries, for example, maybe the Open High SDK, because these libraries often used SOT as the default, and that basically excluded all other schema libraries and also somewhat blocked innovation in this space. And because of that, I reached out to Colin and proved up his own idea again. And I don't remember all the details, but I think I also wrote an initial version for the spec and sent it to them. And then we had calls where we discussed it. I'm not sure how many, but at least a few. And then I think maybe 1 month or so before we published it, already by that time we reached out to many other schema libraries, schema library authors, but probably a month before we published it, I think David joined. And then we were basically a fixed team up by that time. And David also brought in good ideas. And basically we three together then crafted the spec, and I think launched it in December 2024. Yeah, and from there on, it was like a really wide ride. Many popular libraries supported it right away, and many more followed shortly after. I haven't checked the recent numbers. Maybe it's a little bit less because of the Christmas time, but I think we hit or we were close to 60 or 70 million monthly downloads. And for example, SOT, ValiBot, and ArcType don't even include our own NPM package. So if everyone would do that, it would probably be a lot more. And we will probably be close to be one of the biggest NPM packages. But yeah, that's basically also a great part of the specification we created. It's just an interface. You can just, if you want, write the interface yourself. As long as it matches the spec, it will work. And others can use or accept it. And maybe to catch up for some of you that don't know what we're talking about, Standard Schema is a standard interface to work with a schema library. We started with a spec for validation and types. So basically this interface allows you to infer the types from any schema library that supports it, and also do validation. And recently, probably like now 2 months ago or so, we published another spec called Standard Schema that allows you to get the JSON schema for any schema library that supports the spec. And that was probably especially important for all the AI hype, because here we need structured data that LLM can understand to generate a structured output. And of course, also for other areas like open API generation.
So you mentioned right there that the metadata in the schema is useful for AI structured outputs. Can you expand on that? Like how does it find use?
One example is that you build an agent, and an agent usually, also if we build agents on top of LLMs, then we give our LLM tools that can execute various actions. And tools in this case can kind of be seen like tools that we use as humans to do whatever we want to do. That can be, you could, for example, build an agent around existing software that provide APIs, for example, to create a calendar entry or whatever. And for these tools, you usually have structured input and sometimes also structured output. And this is necessary because the tool itself executes custom code that you define. So the LLM has no idea about it. It only has idea about the input and the output. And the LLM has the job to select the right tool and also provide the right input for it. And sometimes the LLM should have additional information to do its job better. And that's where additional metadata comes in. Additional metadata can be a title for an object property, can be a description. For example, if the LLM should pass over a user object, for example, with an email or age or whatever, you can describe what this property is doing, and you could even provide example values so that the LLM understands maybe how the formatting should be. And that basically can help to achieve better results.
That's cool. So, I mean, it really is just like schema for structured output, I guess, like broadly, just like helping the generation. I saw Vercel came out with a like JSON render library recently, which is kind of makes me think in the same vein. It's like the structured output thing is a big topic these days. I mean, maybe a related question while we're on the topic of AI, and I'm curious if how much like thought you've put into this, but like as a library author, when you're thinking about building something like, you know, be it a schema library or some other thing, how do you think about making it work well with like AI tools or LLM integrations? Because it's like there's one thing, the historical thing of like we want to build for humans, and now there's this like new world where like you're also building for bots, and like how does that change your design decisions?
I would say it hasn't changed so far a lot, but it's not because it doesn't make sense. It's probably because ValiBot was created pre-AI hype. ValiBot is now, I think, 2.5 years old, if I'm not wrong. And back then, coding agents weren't used as they are used now. But on the other side, I'm not sure if it would have changed anything. So it is true that especially ValiBot struggled initially because by the time some of the first useful LLMs were trained, ValiBot was not yet that really present in the training data. And that's why the earlier LLMs couldn't really write helpful ValiBot code. And we had another issue. We had a full rewrite of the library in spring 2024. And some of the training data still or a lot of the training data still was based on old ValiBot API, and that made it even complicated. But that was nothing we could have planned. And so nowadays I would say the newer models, they are pretty good in writing ValiBot. And if they are not, you can just provide them our LLM TXT. We have put a lot of work on making that easy. So you have the option on just passing over a list with URLs, and the LLM can then pick and follow it. Or you can provide the entire documentation or just the guides, just the API references. And you can even, if you use the docs and you open a page, just put a .md behind it, and then you get a markdown version, and then you can pass that forward. And I see now more and more tools like Context 7, I think was the name, that indexes docs or also LLM TXTs. And if you provide that as an MCP, then LLM, for example, as part of their planning mode, or even when they're executing things, they can use that to figure out how to get it right and figure out what ValiBot is and how the API and everything works. And I think with that, we are now at a point where it shouldn't be a problem anymore. And I expect that it gets even better this year. I expect that LLMs will try to use more and more updated information and maybe freshly fetches it. And that's why I think it will become less of a problem. But yeah, I'm also curious about what you can do to build a library more AI native. Also with AI native, I mean that AI can easier implement and use it. Maybe that's a topic for this year, but we will see.
Yeah, it's funny how in the end, like good AI ready code really just means like you checked all the boxes of pre-AI good code. Like you have good tests, you have types that are descriptive, you have JSON doc, you have docs. Like if you have all those things, you can kind of distill it down into like a good AI integration. And it's just kind of funny how full circle that is.
Yeah, and I think, for example, simplicity and consistency is also like key on helping AI get the job done. Because if no human understands your library, it's unlikely that AI will do. And if you, for example, ValiBot have a strong mental model that hopefully makes it easier for humans, that should also make it easier for LLMs. And another thing I try to focus a lot on, not providing 10 ways to achieve like the same result. In most cases, there's only one way in ValiBot. And that makes it also a lot easier because if ValiBot code is part of the training data, then the ValiBot code is more consistent. And then it's more likely that the AI will generate the code the user would expect.
Yeah, it makes a lot of sense. Before we sort of run out of time, I would also like to cover the other library you've worked on recently, Formisch, or Formisch, however you say it. Yeah. There are a good number of form libraries out there, and it's a subtly challenging problem. I mean, having written one or two now, at least two, like I'm sure you're much more intimate with this problem domain than most, but
Yeah.
I'm curious, like, what motivated the library, like why forms, and how do you think like this is different than existing solutions?
So modular forms, as I said earlier, was my first public open source project, and it was a form library that had the goal to be modular and small. And that basically inspired later on ValiBot. And I built a form library back then because I was a heavy user of form libraries, and also back then when I used React, when hooks were in beta, I built like the whole form logic myself. That's why I knew many of the pain points, and I tried to fix them and make them better with modular forms. And I think to some degree I was successful, but to some degree, maybe also not. I think API ideas I had were great, and I think that's what many appreciated. And I'm not sure. I think at the same time, Formhouse was started. I don't think he was inspired by modular forms, but we had some similar ideas at least. He later on, Corbinian, joined then 10stack and built 10stack Form, which has also a really similar API design. And the reason why I built it, because I felt like forms are not yet solved. I think React hook forms went in the right direction many, many years ago. But it also felt like over time it got like bigger, more complicated and more fragile, and more error prone. And I basically tried to simplify that and fix it. And modular forms unfortunately had a few problems because of the internal implementation. And this and a few other things motivated me to get it right and build a new form library called Formisch. So Formisch is heavily inspired by modular forms and all the learnings from the past, also inspired by the work I did for ValiBot, and tried to fix all these issues. And another goal was, so modular forms was also available for a few frameworks like React, Solid, Quick. But back then I tried to implement it in a framework agnostic core. It also worked, but it added extra code to the bundle size. And at the end, I decided, okay, screw it, let's just duplicate the code. And that made it, of course, super hard to maintain because we had to do the same edits 4 times. Now with LLMs, that's maybe no longer such a big of a deal, but it's still beneficial if you have a framework agnostic core. And the cool thing with Formisch is that the framework agnostic core does not add any additional load to your bundle, and it does not add any additional load to your runtime performance. And we achieved that with a special build step we built on top of the core package. And what makes Formisch very different from all the other framework agnostic libraries and maybe other libraries in general is that it inserts the reactivity blocks of every framework in the build step. And because of that, the reactivity you get is fully native to the framework you're using. If you use Solid.js, under the hood, it will use Solid.js signals. If you use Quick, it will use their signals. If you use Svelte, and so on, a few, it will be native to your framework. And you can expect a native experience.
Yeah, the API is quite nice. I like how you just like give it a schema and then you're kind of just off to the races. I see in the docs it says it's built on top of ValiBot, but like, could we use like standard schema compliant schema libraries for the schema prop? Like, is it kind of like, would it be possible to switch it out like that?
Yeah, it's possible. Back then, when I started the work on Formisch, it was not yet clear where it is going. I had like ideas on how to improve and fix things, but it was still something probably no one had built in that way before. So there was no blueprint. I had to experiment a lot. And actually, I built it initially framework independent. But then at some point, I decided, okay, screw it. Let's just depend on ValiBot for now to just simplify this part and focus on the part that actually matters to build a newish library. ValiBot is mainly used for types, and also there is like an initialization part. We use the schema to initialize the signals for every state of your form, and that's where we need ValiBot specific code. But besides of that, it's not very specific to ValiBot, and we could outsource that in an adapter style pattern.
Interesting.
We've talked a lot about validation libraries, about building libraries for AI, about compatibility between validation libraries, forms, modular architecture, covered a lot of ground. And we always like to ask a future-facing question. And there's one that I think is interesting here. So in some ways, you're limited by the language capabilities, by the tool capabilities. So we talked a little bit about how the approach of modular architecture for ValiBot can be a little bit limiting because you don't have the IntelliSense like autocomplete, right? You don't have the Zod like dot and it like fills out a method for you. And you could potentially like build a tool for that. But I'm curious, are there like language features or like TypeScript features that you think could improve like how you built ValiBot or like, you know, how you would go about solving this problem? Any like specs on the horizon? There's like, oh yeah, if we had this, like, I mean, like the pipe operator, maybe. Like, is that a thing that you think would like help?
So the pipe operator, probably not. I looked into that, but I'm a bit out of context now because it's probably more than a year ago. I think for a library like ValiBot that does a lot of type calculation would probably help if that would be more flexible or maybe even more powerful. But it's not that I looked into TypeScript that deep to make like direct recommendation. But sometimes calculating, also inferring and calculating complex types can result in a lot of extend checks and can get really deep. And it also seems like that, especially for big projects, this can also affect the TypeScript performance and therefore our editor performance and can make the DX way worse. TypeScript Go will probably improve a lot of that. But that's the first comes to my mind. And other than that, I'm not sure I have to think about it.
Yeah, it would be nice if there were like, it sucks that all TypeScript programming is basically just a bunch of ternaries. Like it's like this pseudo language. It would be so nice if you could like write a little function body somewhere to be like, okay, we have some variables. We don't have to use those as generics. Yeah, there's a lot of room for improvement there, I think.
Yeah, and the code that we as library authors of a library like ValiBot or maybe also Formisch or other libraries write, that is like an area where even the best LLMs struggle completely and give you like nonsense results. Because also most developers haven't or even can't write these types because they can get really highly complex, especially if you want to make them performant. And Formisch has some of these types with our paths where we only recommend you the next path item that is actually valid for the thing that you are building. And yeah, that requires a lot of like research and test and yeah. And I think and hope we got it right Formisch because there were problems with modular forms. And I also think, I haven't looked at any form library, but I think Formisch could be also maybe one of the first libraries that will reach 100% test coverage and will be super stable probably very, very soon. and also available for all major frameworks. And I hope more and more developers take a look at it, because I think it can be the future of form development. And yeah, we will see probably this year where it's going.
Well, that wraps it up for our questions. Thanks for coming on. You've done a lot of really cool work. I love your focus on modularity and small bundle size. It's definitely something that we need in the world. So thanks for coming on and talking about it.
Thank you. Thanks for having me.
Yeah, thanks, Fabian. It's been great to have you. I think like ValiBot is awesome, and the work around Standard Schema and Formisch is all great. I'm really looking for a replacement for React Hook Form. I'm kind of at that place, so it's timely. But yeah, no, it's so great chatting with you. Maybe we'll get a coffee soon.
Thank you.